we'll record the presentation session for this. All right, so let's begin. All right, so let's begin with some of our issues. As we all know that K-12, especially K-12 in higher education, for example, is UMass Boston, where I also am faculty in engineering. What I find is that there are a lot of students who come in, but with the aspiration to become a STEM student, but they are not able to do it. And these are some real stories that we have heard. As for example, this is a real, not the picture or the name, but a student came to me in my class and wanted to join the engineering, but was not able to do it primarily because she didn't have physics background. So if she had done STEM courses in high school, although she had done rocketry, she had done different kinds of activities like robotics, but didn't have the theoretical or the background to survive in the engineering. That's where we started looking into this STEM education problem. We found that there were almost like 1.2 million students drop out, primarily because they are not prepared for the college. And even those who are prepared for the college, only 4% of them would go to STEM field. So we essentially started looking into how we can use adaptive learning in order to create the competency in the students, especially that whole layer about high school student and the first year college, where they need to survive, not only do well in high school to get into good schools, but then also survive in STEM when they join in. And that's where I come up with the Jane story, that she did well, but she wanted to get into engineering, but couldn't do it because of the competency lag. So we have essentially created a whole bunch of STEM courses in a way that we can develop the basic competency, and we receive a National Science Foundation grant, phase 1 and phase 2 both, in order to improve the STEM education using adaptive learning. So if you look at adaptive learning, let me just quickly say, what is the promise of adaptive learning and why everyone talks about adaptive learning nowadays? And number one, that we are looking into a personalized learning experience. We are also looking into prescribe only the content that they need to master so that we are able to figure out what content works for them and provide them feedback in a way that they can understand where they are not doing so well and what learning strategy may work for them, and then provide them real-time remediation so that they can get over their problems and then successfully complete competency building in STEM areas and do well in STEM disciplines like biology, chemistry, engineering, mathematics, etc. So so far what we have seen, most of the adaptive systems are only focusing on things like predictive analytics or item response, and not able to come up with the conceptual framework and how that can be utilized. So we are looking into that. So now, in our case, adaptive, and why we call it adaptive 2.0, because we are different than most of the adaptive learning or adaptive systems you may have come across, like Dreambox, or you may have looked at Adapt Courseware or Newton and things like that. So number one, what we are achieving with our course is we are adapting content to the student preferred learning strategy, and I'll define learning strategy as compared to learning styles in a few minutes. And we are also utilizing effective pedagogical methodology, and which is our main focus. So if you look at most of the technology has no pedagogical framework, and that's where it's very hard to really understand what adaptive learning they are trying to achieve. And because it's not enough that I can tell you how you are doing, give you some practice exams and practice feedback, or take you to a different place in the courseware. But what we want to do is provide them real-time feedback and also remedy the concept that they are really having difficulty with. And so if you look at that's extremely important model to have pedagogical framework and provide both feedback and remedial pathway at the same time, which is what we have achieved. And also providing some linguistic issues, because we find that bilingual students, especially immigrants and bilingual students are not able to quickly adapt to the professorial model of classroom learning. So we provide them language translators, as well as we are fully compliant with 508 ADA compliant for the American Disability Association, and also the issues related with disability. We do work at UMass with the Ross Center of Disability, and we have provided a lot of our tools and technologies there to help those students. So we want playing field equal for everyone, whether you come from different ethnic background or from the school system which were not so hot and didn't prepare you well. We are allowing them to prepare, create the competency by creating better comprehension and retention, increasing course completion and reduce learning time, and obviously making their life much happier than the miserable classroom experience. So how do we do that? So this is our secret sauce, or I would say pedagogical framework. So in this, what we are trying to do is that we are essentially looking into a framework. So without a pedagogical framework, for you essentially now can figure out how to organize content, create learning strategies, make it more student-centric, and also provide social construction. So that's kind of the four-dimensional framework. So learning media, which includes all kinds of text, graphics, audio, video, animation, simulation, then putting all of them in certain learning strategies, providing an interactive interface, and then allowing students to interact amongst themselves in order to create a ecosystem where a student learns well. So let me dissect it a little bit, because this learning cube looks quite complicated. So number one dimension is the media. So whether you read text or look at a graphics or listen to audio or watch a video or engage in animations and simulations, those are all the ways that the information goes into your brain. So their neuronal activities are encouraged because of these kinds of systems and providing different media. But that's not really your learning style. You may be auditory, visual, kinesthetic. Most often people refer to that in the literature, but that's only part of the story, because we are just essentially getting the information to the brain. But then to analyze it, you go through a what I call cognitive process. So based on the cognitive psychology research and also research on artificial intelligence and some of the linguistic models, we have come up with 5 distinct learning strategies. So all content that you looked at in the media part is essentially put into 5 different models where you can now learn step by step, or you can learn by case studies, or by example, which is induction, or you can learn by deductive scenarios played by the interactive activities, or you can even discover new concepts by playing games. So that's where we essentially personalizing experience by looking at what learning strategy resonates with your brain and how it works well. So if you look at here, once we identify some of these activities, then we start feedback mechanism, which is the intelligent feedback, and providing students continuous feedback so they can be, or the learning process become more student-centric by also engaging them into their own animation, simulation, and different kinds of personalized learning environment. So that's where we are making it more student-centric experience rather than, the stage on the stage model from the teacher-centric. So that's a highly interactive experience. But once you learn something, then the question is that can you present that? Can you discuss it amongst your peers? Can you have a chat session on it? So this is where we say the best way for social learning is that you get engaged into discussions and presentations, etc. So that's where we connect them with Twitter and wikis and all of those good stuff. So now they can contribute to it, and amongst their peers they can learn and understand. So this is where we again combine everything together: the media, learning models, what we call is apprentice, incidental, inductive, deductive, and discovery. And these are 5 distinctive, differentiated instructional design. And I think that is music to the ears of instructional people because they understand that everyone learns differently and you have to provide differentiated instruction. And we have achieved that by cognitive psychology models coming out of various learning theories, which I can go into details later on. But so now this is the framework which allows us to take a student and then also assess them which learning strategy works best for them. So we go into assessment process. And so once they go stage 1 assessment, we are looking at their competency and rotating them through 5 distinct learning strategies. And then again assessing them every time they take a turn through different learning strategy to see which learning strategy, which learning models are resonating, and that feedback allows us to then figure out what learning strategy works best for them. And from there, and the reason we are able to identify that because we have sophisticated statistical inference engine, which is our artificial intelligence, or what now we call it machine learning algorithms, which allows us to identify learning strategy by looking at every click they are making on our courses. And that's where we look at the learning strategy usage. We look at the quiz trajectory, how many times they have gone through the quiz and the feedback cycle, and what was the question, what feedback was given, and then content viewed, what content they have looked at, what is the time on each segment, how much time on the task they have put. And then finally, we also look at the cyclic model. So there, every cycle, learning cycle as we call it, there's more and more learning. The system that adapts to a student's neural network of learning and provides continuous intelligent feedback is what we are calling this adaptive learning system, which essentially is based on big data analytics. So there's a lot of buzz now on big data analytics. So what we are doing, we are collecting real-time data coming from all different predictive parameters for a student and the code of the student, analyzing them in the real time and providing them as a feedback to the faculty who is teaching in the classroom. So our systems work in tandem with the classroom, and we call them adaptive resources for the class. So the teacher teaches the way they teach every time, and we do not ask them to change, but we provide them a lot of real-time feedback with these kinds of big analytics charts. So they can see individual student and how they are performing, and what is the correlated learning strategy on the right top. So that student may think that he's an apprentice learner, but we are able to figure out that deductive is the best learning model for them. And so a teacher is sensitized with how their cohort is set up in terms of cognitive learning processes, and then they can modify the classroom instruction in a way. There's both ways. It allows students to learn best with their own learning strategy, also allows teachers to understand how their classes or their cohort is distributed in terms of learning strategy, and then provide the instruction that works the best. And that's where we have this adaptive 2.0 system, which allows us to create the competency for the individual student. So our solution essentially is to create adaptive learning courses in the STEM areas, which becomes ARC. And ARC, what I mean by ARC is adaptive resource for the classroom. So let's say if you're teaching physics course, freshman physics at UMass Boston, or let's say general physics or AP physics in high school, you're essentially going to use our adaptive physics course. And in that way, in this case, Professor Ben Owens from Murphy, North Carolina, has been using our system. And what he finds is that he's able to offer this solution to them. And he teaches about 50 students every year. And what they found is that the student has almost close to 100% competency. And we have done lots of efficacy studies, including from MIT, where this company was spin-off from. So we have MIT Physics Interactive Video Tutor Project, which was well documented, funded by NSF again. We were able to use our adaptive technology and bring the failure rate from 18% at MIT to 4%. And then we obviously created 99.9% completion rate. Because the students were good, but they still were not able to catch up with the competency that was required. We also did some corporate courses, took them from 40% to 97% completion. We also done bilingual population, the Hispanic population, trying to learn English, and we did digital literacy projects for them, and also learn how to use computers. And so we have taken them from 30 to 91%. In IMBA, we have also taken online MBA program from 70% completion on the ground to 91% with adaptive blended learning models. And in our adaptive MOOC, which was done through University of Massachusetts a couple of years back, we had 5 times more completion than MIT edX. And currently in the physics course, we have about 250 students go through our courses, and we find that we have 90 to 95% completion in our courses. So we consistently see in various domains that adaptive 2.0 methodology, where we have a very strong pedagogical framework, real-time feedback, and remediation, we are able to achieve very good learning outcomes. So what about the platform? We have fully developed software platform, which has its own learning management system, which is adaptive learning management system, but we also connect with the existing management systems like Blackboard, as well as Moodle and Canvas and all of those. So we become third-party inclusion to them, but we also have our own instructional design tools, so we can create new instructional models, quiz generation tools. We have essentially full platform to create adaptive learning courses, and we have also been awarded US patent for that. So we have patented adaptive platform, which allows us to author new courses, provide pedagogically effective instruction, do differentiated instructional design in 5 different ways, and also deliver it through various LMS systems. And what we have recently also done very well is to deliver all of this content courses in small chunks by what we call as a nano adaptive apps. So we are doing bidirectional architecture for mobile systems, and we support Windows. We also support Android and Apple iOS platforms. So you can get our courses, or what we call as bite-sized courses, as nano adaptive courses as apps. So these nano adaptive apps essentially provide one concept at a time. For let's say physics, we have 16 apps covering the entire physics 1 and physics 2 for freshman physics, and that is connected to our server. So we also do interactive exercises. All that data goes to our server. So a student can either take our course through apps, or they can connect online. And both of that data is monitored and provided back to the faculty. Obviously, we also support PCs and tablets, etc. And recently, we are also introducing now, which is where we got the new National Science Foundation funding to create brainwave adaptive learning. So this is our future model, which we'll be introducing soon, where we are putting electroencephalogram EEG headbands, as you can see here, student wearing that. We just conducted the pilot study with 35 students at UMB. What we found is that we are able to identify learning strategy of learners much faster than the traditional Markovian statistical model or statistical inference model that we use, which takes many days to understand the learner behavior. But with Brainwave, we are able to learn that in few hours. So to summarize, we have a customization for the faculty. We work very close to your faculty, make sure that we connect with their course and provide the adaptive resources for the classroom. We do not want them to change the way they teach. This essentially works both for online faculty, online courses, as well as classroom. And it improves the productivity for teachers because now they know how students are learning. It increases the completion rates, which makes the teacher looks very good. They are very happy with our courses because it reduces their burden on taking care of individual students. And they can also deliver courses through all kinds of medium, iPhones, tablets, PCs, etc. And we are on a Amazon Web Services highly scalable cloud architecture. So whether you have 50 students or 500,000 students, we can accommodate that and connect through your Blackboard or any of your LMS and make your LMS highly adaptive. And then we are content agnostic. So if you also want to create your own differentiated instructional design courses, we have a full toolkit where your staff of instructional design can take advantage of our adaptive learning engine and convert the highly unmotivated online Blackboard courses into highly engaging adaptive courses without students even realizing that they are using Blackboard, but now the Blackboard is highly adaptive for that. So let me stop here and take some questions as I set up for the quick demonstration.
I guess I'll go first. You had, we can go perhaps after the demonstration, if you can explain a little bit more about how you first came up with the 5 different learning strategies. Maybe give us a little bit more in-depth explanation as to how that works.
Sure. And I think that will become very clear as I set up the demonstration and take you through our physics course, which is our adaptive physics course, which we call Fundamentals of Physics. So Wendy, do you have any questions? Hello? Jim, can you hear me?
Yeah, I can hear you. I don't have any questions at this point.
All right. Okay, no problem. So why don't I take you through demonstration and then we can open it up for more discussion. And then I'll explain how we came up with 5 distinct learning strategies, what was the theoretical background for that, and how we arrived at 5 strategies like apprentice, incidental, inductive, deductive, and discovery. So let's do a quick demonstration. So think like you want to learn physics and you connect to our website. I'll connect through. So first thing you will do is that you'll go to our website and find your school, including UMass Boston. So I can see that UMass Boston is listed. And so we have Rahul Kulkarni, Brian Kaufman, or myself as physics instructor, or I may be at Lowell, or University of South Bend in Indiana. So what happens, we essentially put the school name and then we put the name of the faculty. So recently we had one of the historical black colleges in University, Alabama A&M University connect with us. So their students now will find their faculty, Patty Padmaja Gojila, and then click on that, and with that they can all log in. So once they define the instructor, they are become part of the class of the instructor. So it's very, very easy onboarding process. So once you register, and that's where you can do self-registration. Or if the university wants to send us a list of their students, we can also batch register them on our system. So I'm going to log in as faculty. So as I go in, I click on the course. So as I get into the course, first thing is that I'm given instruction by Avatar.
Start with basics. First off, the page that you are on is called your dashboard. The dashboard screen allows you to access recent activities and read messages or announcements that pertain to each course.
So we know that a lot of students do not want to read our manual, so we have audio instruction for them how to use our system. But for 508 compliance, we also have everything as its own text version, and the screen readers can read those texts. So for visually impaired, we have full compliance here. So once you get the instruction, you go in, and the first thing you will do is take a learning strategies test. And these are 25 questions which are trying to ascertain how you think, how you declare yourself as the thinker. You say, you like to read the textbook before solving problems? You say, yes, I like that. You prefer to learn content from mentors? Maybe not that much, but okay, yes. You prefer gradual progression of content before drawing the conclusion? Yes, I like that. So I will go through this yes and no answers. I'll say, you prefer gradual, so as I said, learning concept, does it help you to write steps down? No, I don't do that, but I do like to solve problems, so I do yes. So when I do all these yes and no answers and I submit this survey, which is called Learning Strategies Test, then the system says that, okay, looks like I'm an apprentice learner, so I can continue now to pre-test. So what we always do is that for every course, and we have physics and statistics, computer programming, and also algebra course, in the STEM areas, and we are also developing an engineering design course. So in this, every course, they first do a pre-test so that we know what is their pre-test competency. So this is a simple multiple choice in order to ascertain what is your initial competency in the subject matter, and then we find what is the gain in your learning performance. So I submit that, and with that it says I got 2 out of 10. So I record that competency. I have very low competency, which is fine, and that's what we want to find out. What kind of cohort are we dealing with? Are these students already know about the subject or they don't? So once we go in with that pretest, we go to the first concept in physics called kinematics. So each concept is divided into 6 sub-concepts or 5 sub-concepts. And then you have to take a practice quiz. And once you do practice quiz, then you have to take an assessment quiz. So there is an assessment quiz. You also have to do 2 topics, for example. We'll do kinematics and Newton's laws. And this test, which is assessment test, is graded, while the practice test is non-graded. So you can take practice test as many times as you want. So this is the general structure. But now let me show you how does our learning pedagogy work. So we start with, let's say, it says that I'm an apprentice learner, so let's start with that. And we take one concept, like let's say equation of motion, and see how does that really work for me. So I'm going to go, this is apprentice, so everything is provided step by step. There are some graphical animations. I can look at those animations and see how this runner is going through the runway, and then what is the speed, what is the velocity vector, etc. Now with that, I'm able to find the distance, and I want to find the displacement. So there is a difference between velocity and speed. Immediately, I learned that by text and graphics. So that's my apprentice model. But if it was not my model, so I can take you through 5 distinct learning strategies first and see how do they differ. Let's say if I was incidental and I wanted to learn the same equation of motion, I'll have a very distinctive instructional model. So now I have the model showing up here. And so in this case, there are a lot of videos that are connected. And then
they're into the turn and punching for
so now we are showing the acceleration. We are showing a lot of these videos that are available to you. So based on real life scenarios, we explain to you what is the so looking at x is equal to 0, and the video that you watch, we ask you certain questions, and then based on that, we are able to show you all the answers. So now in this case, you can also see a lecture. So you can hear the physics lecture. So this is incidental learning, is more video oriented and based on the case studies. So a lot of real life scenarios. So I may be incidental learner, so I will learn very differently than apprentice. Let's say if I'm inductive learner and I like examples. So in this case, the same thing I'm going to encounter various solved examples. So a car that is driven from x is equal to 0 to x is equal to 10. So now we know how much distance you have covered, what is your velocity, and what is your acceleration. So we are trying to learn these concepts by solving problems. And so that's the inductive learning model. Let's say I said, no, I think I'm deductive, so how would I learn there? And deductive is more interactive learning. So I will be given a problem, and I'll be asked to solve it, and then interactively look at what is the right answer. So I'm given certain clues, but I'm not given the answer right away. And I have to really struggle or interact with the system and say, okay, let's look at this. Okay, good job. So with that, now I've posed another problem, and then I have to solve that with certain clues. So this is the way we develop a lot of interactivity. In some cases, you have to match the concept, or in some cases, you have to interact with the various options. So this is interactive learning for the same concept. So let's say I said, no, I really need more challenge. Show me a discovery model for the same concept, which is equation of motion. And what we are able to find is that, so if you look at there, then we are able to look at in discovery model is that we can see that this is like experiment. So in this case, we are going to do drag and drop. and various solving puzzles. And once we solve the puzzle, then we can go to the next and the next and the next, etc. So this is how we are able to use discovery. And then at the end, we are going to take a test. So this is a randomized test, so I can take that as many times as I want. And these are the questions coming from the freshman physics or AP physics. And as you can see, these are not just multiple choice, but these are also short answer questions. And I have to really do calculations on the side with a calculator to find those answers and put them in. So, and this is set up just as the AP physics or freshman physics course would work. And we have a question pool from where of 60 questions, and then we draw about 12 questions out of that. So about 5 times more questions are generated, are put in the pool, and then we are randomly creating graphical questions. In some cases, there are also video questions or short answer questions, or even interactive questions that you may encounter. So, but our this assessment model is randomized, so you can take this test as many times, and we do not grade practice tests. We want you to achieve a competency of 80% or better, and that's how you will progress. And once you achieve the 80% competency by going through these cycles, revision cycles, then when I took the test, I'll get a feedback.
You've made a good try, but could do better. You will be happy to note that I have created a short revision course that will help you get over your problems. Please select the revision icon to continue.
So the way you see is that I got 1 out of 20, so obviously says you made a good try. It's quite a gentle system, but say your competency is at a poor level. So I need to now enter the revision stream, which I can do, which is generated just for me. It's a dynamically generated content. But at the same time, I'm now given idea about how I've been learning. So I've been using Apprentice a lot. I've taken tests many times. I've gone up and down, content viewed. I've looked at different topics. I've looked at time on the segment. And then if you look at here, we're also looking at that although I thought I'm apprentice, looks like I'm deductive. And that's quite a revelation for me because I thought I was an apprentice learner. So the good news here is that the system has created a revision stream for you. And now this short course did not exist before. It was dynamically generated based on your click stream and to now understand what you have missed and what you need to learn. So now I can get more examples here. I'm given more additional help. I can look at different animations to that. I can even solve some problem solutions. I can also watch a video because I may have missed certain part of the video. And then I'm also given a glossary of terms. So I revise that, all of that. And then I'm also given a knowledge check. So with this knowledge check, I will revise all this and retake the quiz. And so I can go back to retake the quiz. And so now I'll get completely different randomized question, which is a graphical question. And then if I take the test, or I can also decide, no, I want to go back. And so let's see where the system sends me. So I'm going to click back to the course. So this is where my adaptive achievements show up. So in this case, it says I was an apprentice. In fact, I was in discovery, which was my last learning strategy, which I showed you. Didn't do so well, so I'm going to be sent back to apprentice. So now if I click on this, then I'm sent back to apprentice, and I'm going to go through the course now in apprentice. And as I take the quiz again, I may be rotated one more time. So I think by rotating student, we are generating a lot of statistics, as you saw. And at the end of that, once they reach 80% competency through the practice quiz where they are not penalized, they can take that as many times. Then once they take the final test, what we found is that their performance is excellent because they've already generated the competency by using different learning strategies. And what we also find is that ultimately, once the student learns that I'm deductive, then what they do is that they go and they choose deductive, and that works well for them. Now their progress is much faster, and now they know that I'm going to learn by interactivity, and so I will do the these interactive video exercises. So they are given a lot of these interactive exercises now, and then there are questions about it. So with this, now you can see that they will be now asked to interact with the system, and that's the way they are going. I think I'm on the topics. Let's go back to one-dimensional discussion and deductive model. So now you can see that in this case, you are given a lot of these examples, and then you have to interact and answer the questions as you go through it. So this gives you a very quick overview on how the system works. But let me also show you a few other things that are important. So as a faculty, as I go to Professor Corner, so as a faculty, I have to look at my class roster. So I know exactly which are the students. They can put their pictures if they want. But then I can look at their grades. I can look at how they have been performing. And so all of these students are given, so you can look at student 111, and you can look at their report. So I think all of these reporting function, grade function is all provided to you right at your fingertips. And the other thing we also do is that you can add more resources. I can send discussion topics to them. I can also do assignment management. So these are all Professor Corner, which are similar to the LMSs that you may have seen it. But in this case, I know exactly with the red, yellow, and green, which are the red students, which are the yellow students, which are doing well, and I can look at the student submission, etc. But the most important here is the Learner Analytics dashboard. I'll take you there. So in this case, I can see the entire class. So now this gives me entire class. It looks like in my cohort, there are very few discovery people, lots of inductive and apprentice, and incidental. Now I can see how the class is doing, how they are progressing. Now if I want to see an individual student, so I can go to that student and look at that. And this is my class. And I can, let's say, Brianna Callahan. And then I click on submit. So I can look at individual learner and how they have been doing. So in this case, student looks like has only used one learning strategy, not taken any test, etc. I will know exactly what their progress is and what their trajectories are. So if I go to Naomi Crandall, submit that. So now let me see what she has done. So in this case, you can see that learning strategy usage, she has done apprentice only, one test she has taken, and what content she has viewed, etc. is all coming up. So you can see the progress, you can see the grades. You can also look at the big data analytics for the entire classroom. So now this gives me cohort data and provides me the whole information, but I have to then click the entire data and look at that. A lot of information is on my fingertips to manage my my students. And then, of course, there is a grade book which gets synced with the Blackboard or Canvas, whatever LMS that you are using. So these grades are sent back using LTI Connect, so that you do not have to change your LMS. You are just making your LMS highly adaptive system. So let me stop here and see if you have any questions. So the question that was asked to me, yeah, go ahead, Wendy.
Yes. I have a couple of questions. I want to say this is very impressive. Clearly, you've done tremendous amount of work and have applied. I imagine you've been building this over a period of time. So I want to say that I am impressed. I love that four-dimensionality. I have a couple of questions and would like to understand more about the assessment, but it seems like you know, obviously there's a lot behind developing each one of these kinds of pedagogies for the different types of learners. What courses or subject areas do you have developed is this something that you're selling in terms of subject content or in terms of tool?
So yeah, that's an excellent question. So we essentially, as you said correctly, we have taken many years to build this, starting from my research at MIT as the principal educational architect and director of Hypermedia Lab. We did lots of pedagogical experiments first, then we put together a framework, and in the last 3-4 years, we have put together the entire software while we also received our patent. So yes, a lot of work has gone in over, I would say, 5 to 7 years of thinking and putting it all together. In terms of, so first we build the tool, and especially for differentiated instructional design, because that's one of the most difficult things to achieve in a way that you are able to understand that. So pedagogical framework, what we are able to achieve there, and is that we have automated tool that takes the content that you may have created. Let's say Blackboard creates a content, what they call cartridge. So we are able to take that, and then obviously we have to do additional work, where we have our instructional design team, and then convert that into 5 distinct learning strategy and adaptive feedback. So to come back to your assessment question, we are essentially doing assessments, which are 2 types. We are doing, in fact, multiple types, but I'll just take you through few. One is the pre-test, which is a simple multiple choice. But then we are allowing them to do practice tests, where they can rotate through our learning strategies and figure out no matter what learning strategy they take, but we want them to reach the 80% competency. And then there is a assessment, which essentially, and these are all auto-graded. So faculty loves it because they don't have to grade these. And then there's also a graded assessment, which is also what we saw at the end of the course segment. You have to go and then take the test. So that is what we call the assessment test, which is graded. But besides that, faculty can also do their own usual assignments. So they can provide the assignments, upload those assignments. So we have full assignment model, but you can also use Blackboard if you are used to that. But what we are doing is that we are combining the adaptive learning assessment with their classroom assessment. So that's how our assessment becomes very, very well. And what we find is that the faculty, including at UMB, when they use our adaptive resource in the physics, and many faculty have tried this now in the physics, and I'll come back to what are the other courses which we are doing. But in that case, they use that like 20% of their class homework is attached to getting 80% competency. And they have to get competence in every concept. As the class is going through, they have to go through our content, and this is independent of the textbook. So no matter what textbook you are using, this is the content created for them to master the concepts. In terms of content, we are following the trajectory of essentially STEM courses. So although we are a tools company, in a way we are a platform company, and we are working with many other universities to create their online programs based on their assessment requirements. But we are also creating, based on the NSF funding, we are also creating our own content. And in that content, what we are seeing here is that we are focusing on about 10 to 12 STEM courses, which I'll just put it on in front of you. What are those courses that we are working on?
Can you hear me now? I don't know when this is. No, good. You can still hear me. So I don't know that we have ever met in person, and I'd very much like to meet you, since maybe you're just upstairs from me if you're in the BBC on those days. Yeah. But I oversee the Instructional Design Master's program. And that's why in particular, I mean, I think what you have here is unique and it is intelligent. You know, what the idea of the STEM courses is great. The question is really, you know, the other thing is, like, I'm an associate dean here. I'm learning design and technology, and the idea that I'm always striving for is how do we create experiences of learning that are often online or are highly digital in nature, that are immersive, that are engaging, that you learn from, all of these kinds of things. So I take those kinds of ideas as I, tip over towards what are the courses we offer in our instructional design program. Even theory. I mean, I could see taking your 4-dimensional block and building a course off of that. I mean, you've got a lot of good stuff here.
Yeah, Wendy, that is an excellent idea. In fact, what I did, I was invited by, Delhi University in India. Few of us from UMB went there. I trained 60 faculty there on how to create adaptive course in 5 days.
Wow.
And at the end of the 5 days, they have to create a course. So they've created 10 groups of 6 faculty each, and then they all presented, and it was a wonderful presentation. We do have some videos of that. So
right.
I think to incorporate this whole tool in your classroom and say that, okay, use this now and show us how you understand, number one, pedagogy, how you understand instructional design, and how you can create your own course. And then you
also are talking about technology, you're talking about assessment, you're talking about learning theory. There's so many things here.
Yes, that's true. So definitely let's have a meeting time, maybe this week some time. I can come down or you can come to VDC. And let's figure out how we can incorporate that within the framework of UMB.
Right, well, we can at least start a conversation. I think that would be very intriguing.
Okay, sounds great. Okay.
But I know there's that other fellow online. I don't want to take all the time here.
So Jim, do you have any questions? Hello?
No, I don't. I'm really looking at this from a completely different perspective. We were asked by Anthony Scabella about some medical content for health literacy. And also, I was just getting a feel for what the IntelliDept process is. So I think I understand the basics of it and see how it could be used in the medical world to increase health literacy. Sure.
Yeah.
In fact, that connects with what Wendy you were talking about, the nursing content and geriatric content. In fact, we are also working with Edtronics, if you know Professor Edtronic, which is right across VDC, where we are using the baby lab. So in the baby lab, we are also trying to understand the stress in the mothers and how they deal with the infants when there is a stress increase. So we are doing some brainwave adaptive learning with them to understand how we can help them cope with the stress. So, and also some of the, the nursing content, which also requires some anatomy, physiology. We have dealt with that in different situations. So in terms of the healthcare, just wanted to let you know, Jim, is that we are working with a company in Pennsylvania, which is called Amity Care. They provide, the support for autistic adults. So we are working with the long-term care facility, or what sometimes they call it senior care facilities as well, where we are doing what we call as adaptive learning for the care providers. So when the care providers come in, they all carry their laptops or desktops or even iPhone. So we are delivering them what we call location-based training. So if they are in the bathroom, if they have to give a bath to autistic children, we show them a video, what is the right way to do it. If they have to feed them in, let's say they are now in the dining room, then immediately the video shows up, which is related to the dining. So what we have done IoT, so Internet of Things. So what we have made our content sensitive to the location where they are in the healthcare provision, so that we can we are doing 3 things: training, tracking, and compliance. So we are making sure that they are well trained, because there's so much problem with the ill-trained, the healthcare providers. Then we are also tracking that they administered what they were supposed to do, like diabetic patient needs to be given certain insulin. If they forgot, we are able to send that information to their supervisor saying that he didn't complete the task. And the third one, we are also looking at using all of that information which they have to submit to the state in order to get compliance points so that they can get paid from the state government. So there's another part of this adaptive system. Yeah, go ahead, Wendy.
What I was going to say, prior to coming to UMass Boston, I was at Case Western Reserve and dealt a lot with the medical world. And there's a lot of attention, and Jim, I don't know if this is your world or not, but a lot of attention on translational science. And that means the work that's being done in the laboratories, how that can actually get to the clinicians. And, you know, I could even see a tool like this could work for that, because really it is education. So it just came to my mind.
Yeah, no, exactly. It's all about keeping up. And knowledge is powerful and helpful, life-saving, and cost-saving.
Great. Any other questions?
Not for me. I just want to figure out how to create in this thing. I got to talk to you more and find out.
All right, we'll do that. Okay, thank you, Wendy. Thank you, Jim, for joining today, and we'll keep the conversation going.
Okay, thanks so much.
Have a good day. Goodbye.
Bye.
Thank you. Bye.